Okay, we're here with our student Jordan to talk about graphing linear inequalities. You ready?
Yep.
Okay, so first of all, let's just talk about what these words mean. Linear and inequality. Linear just means it's going to be a straight line, and inequality just means it's going to have one of the inequality symbols, like greater than or equal to, less than or equal to, greater than or less than, instead of an equal sign. If it were an equal sign, we would call it an equation, okay?
Okay.
All right. Good. So let's look at a linear inequality. Here we have, it's like a linear equation because it's in y equals mx plus b form, but it has this inequality symbol. So it's a linear inequality, and we're going to go ahead and graph it over here on this graph. And we're going to follow a few steps that we'll always follow when we're graphing linear inequalities. So the first thing you do is you graph the inequality as if it were a line. So we're going to graph a line that's y equals negative 3x plus 6. Okay? All right. Then we're going to, if it's a or equal to inequality, like less than or equal to or greater than or equal to, we're going to make the line solid. If it's less than or greater than, we're going to make it a dashed line, meaning that it can't be on the line, it can only be less than or greater than. But if it could be equal to the line, then we make it solid. And then we're going to test a point on either side of the line. And you'll see, I always like to test the point 0, 0. And that way we know which way to shade, because we're talking about situations where something can be greater than the line or less than the line. And so we want to shade all the points that fit for that. Okay? Ready to go?
Yeah.
All right, so let's look at this equation right here, or this inequality, I should say. And let's pretend it were an equation, y equals negative 3x plus 6. So this is in mx plus b form. So which part of is the m or the b, the y-intercept?
B.
B, right? So what is going to be the point where this line crosses the y-axis?
0, 6.
0, 6. Okay, good. So let's go ahead and graph that. Okay, great. Now, what is the slope, the m of this?
Negative 3.
Okay, good. So that means that each time that x goes up 1, y goes down 3. So we're going to go ahead and move over 1 and down 3. So we get to the point 1, 3. Does that make sense to you?
Yeah.
Okay, great. So now, is this one of the or equal to inequalities, or is it just a less than or greater than?
It's an or equal to inequality.
So, good. So are we going to do a solid or a dashed line?
Solid line.
Solid line. Good. So let's go ahead and graph that. Okay, so we've gotten to the point where we've graphed the line with the right kind of a line, and now we need to test a point. Now, to me, it's always easiest to test 0, 0, the origin, unless the line is going through the origin, in which case you can't test that. You have to test something that's not on the line, because you want to understand if this side of the line works or if this side of the line works, because that's the way you're going to shade. Make sense?
Yeah.
Okay, good. So let's go ahead and test the point 0, 0. And what we're going to do is we're going to put 0 in for x and 0 in for y. We're just going to go ahead and write our inequality out like this. Okay? So then we're going to go ahead and start solving it. What is negative 3 times 0?
0.
Okay, so we'll just keep writing this. Now we have 0 is less than or equal to 0 plus 6. What's 0 plus 6?
6.
6. So we have 0 is less than or equal to 6. Is that true?
Yeah.
Okay, good. So we'll write true there, and that means that this point works. This point right here fits this inequality. So that means that all the points on this side of the line fit the inequality. So we're going to go ahead and shade that whole side. Does that make sense?
Yep.
Okay, that means every single point over here is a solution to this inequality here. So unlike a linear equation, which only has solutions on a line, this has solutions in a whole part of the coordinate plane. Make sense?
Mm-hmm.
Okay, good. Now, let's take a look at the kind of the opposite inequality. I'll write it right over here, which is y is greater than or equal to negative 3x plus this. This was less than or equal to, this is greater than or equal to. And really quickly, let's go ahead and graph it. We already have the line, because it's going to be the exact same line, right?
Right.
Okay, now let's test that point 0, 0. So when we test 0, 0, we put it in there. We know that negative 3 times 0 is still 0, so we have 0 plus 6. And now we get down to 0 is greater than or equal to 6. Is that true?
No.
So we write false here, and you shouldn't get tripped up and say, well, wait a second, did I make a mistake? No, we're just testing this point. And we know that that point is not going to be part of the shaded area. So the shaded area is going to be on the other side of the line over here, and so that's what we would shade to graph this inequality. Does that make sense?
Yep.
Okay, great. So now let's do just one other example. I'm going to go back to this inequality, but I'm just going to take off the or equal to. So it's just going to be y is less than negative 3x plus 6. Can you describe what that graph should look like?
It should be a dashed line instead of a solid line.
Yep, so it should be just like this, except for it's a dashed line. See that? Does that make sense? Is that what you expected?
Yep.
Okay, good. Which means that all of these can be solutions, but not the things that are right on the line, because it has to be less than. It can't be equal to. And so, really, why do we graph these inequalities? Well, it makes it really easy to see where the solutions are. So when you apply this stuff to the real world, you'll be able to say anything that's over here or anything that's over here will fit my inequality, fit my situation in the real world, and then I'll know where I can act. Does that make sense?
Yeah.
Great job.